The two red circles represent an atom of the element oxygen. The gray circles represent atoms of the element hydrogen. The green lines connecting the circles show that these atoms are chemically bonded together. Chemical bonding occurs between atoms to form new substances, like molecules. Chemical bonds can also form between molecules to hold them close together. Remember that tower and the building blocks? If you were to glue the building blocks of the tower together, the glue would represent bonding. And just like your glued blocks, chemical bonds require energy to be put together and to be broken apart. So here's chemical and chemical bonding. Chemical is a substance that is made of atoms or molecules which cannot be broken down without changing it into something else. Chemical bonding, a lasting attraction between atoms that forms a molecule or a chemical compound. Okay, so now what I want you to do is get out your Play-Doh and get out your toothpicks and make sure you have your Making Molecules worksheet here. It's not a worksheet, it's a guide. The first one that we're going to do is the hydrogen peroxide. We're going to do this one together. So go ahead and use two different colors of Play-Doh, and I want you to make these two oxygen elements slightly larger than the hydrogen. Slightly larger. So make sure that they're different colors too, so that you can see the difference. So what you're going to do is make your circles, make your balls. You're going to make two balls of one color, and then you're going to make two balls of another color that are slightly smaller. You're going to use the toothpicks within each chemical bond where two atoms connect. So I would have a smaller hydrogen, a slightly larger oxygen connected with a toothpick. When you're done, go to the next slide. Oh, I also want you to get out your white piece of paper, and on your paper, I want you to write very top, elements, atoms, and molecules. This is where you are going to draw your molecules. You're going to draw, so you just did hydrogen peroxide. You should be able to, after you construct your molecule, your hydrogen peroxide molecule, you should be able to draw it on your sheet right here. Now make sure after you're done drawing your molecule that you write the correct molecular formula, which is the name, right, below or around your drawing. So you're basically, for the first one, you're going to do H2O2. That is hydrogen peroxide. Two hydrogens, two oxygens. Okay, so now you're ready to go. This is all on you. This is what I want you to bring to class. I want you to bring to class your paper that has the elements, atoms, and molecules written up at top, and your 3 drawings. God created water for many uses. All of God's living creations need water to survive. Water is also essential in cleansing the earth during rain. The water cycle allows water to be transported all over the world. Read Genesis 1, 6-7. Our Creator, knowing that water is essential, supplied water in oceans, lakes, and streams, and above the earth in clouds. The water molecule has one oxygen atom in the center and two hydrogen atoms placed approximately at 4 o'clock and 8 o'clock. So I'm not sure where the 4 o'clock and 8 o'clock is on this page here with this picture, but that is the description that they gave. So maybe if you think about a clock, where would the 4 o'clock be? That's where you're going to put one of the toothpicks. And where would the 8 o'clock be? And that's where you're going to put another toothpick for within the oxygen atom. And then you're going to put your hydrogen Play-Doh ball slightly smaller than the oxygen on there. I want you to draw a picture and make sure that you have its chemical formula, which is H2O. Carbon dioxide. This is one carbon in the middle and two slightly smaller oxygens. So you're going to need two different colors, and you're going to need to make one larger ball, which would be the carbon, and two smaller, which would be the oxygen. And now you'll notice that there's two chemical bonds here. So let's go ahead and read this. Carbon dioxide is incredibly fascinating because it is the gas that we breathe out from our lungs, which plants need, in addition to water, to make food and release oxygen back into the environment. Observing nature creates a sense of serenity and appreciation for God's creations. The next time you look at a leaf, you will be able to have greater admiration for the wisdom that God has in creating a cycle that allows plants to survive through the use of carbon dioxide, which we as humans produce. The carbon dioxide molecule has one carbon atom at its center and two oxygen atoms that are linear on opposite sides from the carbon. Notice there are two shorter bonds for each oxygen to carbon. Use two toothpicks for each side. And don't forget to label it. It's CO2, carbon dioxide. The last one we have is oxygen, O2. Oxygen can refer to the name of the element oxygen and also to molecular oxygen, which is found in air, that animals need to survive. Plants release oxygen into our environment. Interestingly, oxygen is not the only type of gas that exists in the air we breathe. In fact, most of the air is made up of another gaseous molecule called nitrogen. Like oxygen, nitrogen is also the name of a molecule that is formed when two nitrogen atoms bond together. The oxygen molecule has two oxygen atoms bonded together in a linear fashion. You'll notice you're going to need two toothpicks here. You're going to only use one color and make sure that both of those balls, those spheres, are the same size because they are the same atom. They are an oxygen atom. So the models that you make are representations of the way these atoms would look. Isn't it interesting how these same building blocks can form completely different substances depending on which element to which they bond? For example, the oxygen used to form the oxygen we breathe is the same oxygen used to form water. When one type of atom forms a bond with another type of atom, they form new substances that can look completely different from what they were before. We will look more into chemical changes in a later lesson. It's important to remember that atoms and molecules are extremely tiny and can barely be seen with even the most powerful microscopes. to give you some idea of how small these molecules are. In 1 cup of water, 1 cup of water, there are that many water molecules. Now, if you can come to class and tell me what that number is, I will be shocked, because that is a humongous number. It has taken scientists many decades of testing to come to the knowledge we have today of molecules and atoms. So carbon is a very common element. Carbon is found in specific kinds of molecules that make up about 18% of your body. Pure carbon can be found in different forms. The brittle lead in a pencil is actually not made out of lead, but a type of carbon called graphite. While graphite may break under pressure, another form of carbon produces one of the strongest rocks found on Earth, diamonds. The images above are the molecular structures of A, diamonds, and B, graphite. The round circles represent carbon atoms, and the connecting lines represent bonds. Graphite occurs in sheets that are weakly held together and will easily pull apart, whereas diamonds form strong structural bonds. Isn't that interesting? That what is found in your pencil, graphite, is made up of the same structures, the same atoms as diamonds. Thank you for watching. Look for next week's follow-up of the Elements book, Part 2, where we're going to look at an atom and the periodic table.